Okay, let's add a few more points about emissions from agricultural sector. Of course, we'll be repeating a couple of points, I'm sure, and then close this book. I may add things from elsewhere if I find them relevant to this theme of carbon footprint of everything on the planet. Of course, you can keep adding, but I think the point has been made. So greenhouse gas emissions from agriculture world levels 1991 to 2014, breakdown of greenhouse gas emissions within the agricultural sector by source measured in gigagrams of carbon dioxide equivalent. So we have again included N2O and methane at least. Carbon dioxide equivalents measure the total greenhouse gas potential of the full combination of gases weighted by their relative warming impacts, as you know by now. So here are gigagrams. Here is the time going from 91 to 2014. Enteric fermentation, so livestock methane contribution is always a major contributor. Agricultural soils, N2O and methane together. Synthetic nitrogen fertilizers, manure management, and crop residues. Okay, food greenhouse gas emissions across the supply chain. We are looking at land use change, farm, animal feed, processing, transport, retail, and packaging. And we are looking here in greenhouse gas emissions per kilogram of food product. There are many ways to do it. You can look at per kilogram, per calorie, per protein weight, and so on and so forth, because people choose food for various reasons. Some people choose high protein, and whether that protein comes with low CO2 footprint or high CO2 footprint should be kept in mind. Some people prefer to choose calorie-based diets, and so on and so forth. So here you look at these various combinations, and beef jumps out ahead of everybody in terms of the contributions from farm and land use. We'll look at this in another way. Lamb and mutton are here, but when we look at calories and protein, lamb and mutton may come out ahead. Cheese, dairy products, so beef in dairy herd. Chocolate is remarkably bad for carbon footprint, especially if you look at protein intake from chocolate, if you're into getting proteins from chocolate. Coffee, prawns, palm oil, pig meat, poultry meat, olive oil, fish, eggs, rice, and so on down here to nuts, which can have negative footprints because nuts have a negative land use change figure. You can read the details, it's very small letters. So here CO2 emissions from most plant-based products are as much as 10 to 25 times lower than most animal-based products. Factors such as transport distance, packaging, or specific farm methods are often small compared to importance of food type. Okay, so you have to decide which factor is contributing to the food that you are consuming. Global greenhouse gas emissions from food production. Here is the global emissions at 52.3 billion tons of CO2 equivalents. Again, you have to be sure what is being looked at, CO2 equivalent, or carbon. So out of the total, agriculture, we said before, was 18.4, but here we're combining food, which adds up to 26%. And if we expand that, land use change, crop production, livestock and fisheries, and the supply chain contribute together. And you can see within each you have land use for human food, land use for livestock, which is double the human food, crops for human food, crops for animal feed. That's a significant fraction. Livestock and fish farms here, and so on. So you have to keep in mind where it all comes from. If you look at the table of showing 6 economies whose food systems produce the most emissions: China, 13.5% of the global total. Indonesia, surprisingly, 8.8%. Palm oil is one of them, I suspect, and fisheries. US, Brazil, EU, and India. So not necessarily the countries you would expect in terms of Indonesia and India being high here, but a lot of these countries also export food. So if you look at embedded carbon, then this story may change in terms of where the carbon is emitted and where it's consumed. Okay. How much of global greenhouse gas emissions come from the food system? Another way to look at it, there are two estimates here, one from 2018 and one from 2021. The methodologies differ as well, not just the dates. So here it's 13.6 billion tons of CO2 equivalent from food. That's 26% of the global greenhouse gas emissions, as we saw here. And the newer estimate says 17.9 billion tons of CO2 equivalent, and that's 34% of greenhouse gas emissions. Again, you have land use change, agricultural production, and supply chain. The relative contributions here have changed, as well as the total. So this is split into supply chain and post-retail. So post-retail itself here is adding 2.1 billion tons, and then the contribution of land use change here is 5.7 billion tons as opposed to 3.2 billion tons. Okay, the Kripa et al. Estimate higher land use emissions since it allocates all deforestation to agriculture. So there are methodological differences as well. This estimate assigned only 60% of deforestation to agriculture and food. So how can you justify these kind of allocations? You have to read the papers. The authors justify, the reviewers accept, and then they get published. Greenhouse gas emissions per kilogram of food products. So here, instead of looking at just emissions, we are going after per kilogram. Again, the greenhouse gas emissions are measured in kilograms of carbon dioxide equivalents per kilogram of food product. This means that non-CO2 greenhouse gases are included and weighted by their relative warming impact, as we said before. Beef again is the highest, lamb and mutton, beef for dairy herd, prawns, cheese, and so on down to nuts, as we have seen before. Slightly different way of looking at things, but it does help in terms of how to manage or reduce emissions. A global switch to veganism would deliver the largest emission savings. So this is the savings by going vegan or vegetarian, flexitarian, healthy diet, pescatarian, fair and frugal, climate carnivore, and Mediterranean food. So depending on which diet you use relative to a certain reference diet, these are your savings. Makes sense. Dairy milk emissions are more than double that of plant-based alternatives. So we looked at this before when we looked at milk. There is dairy milk in terms of kilograms CO2 equivalent, rice milk, soy milk, oat milk, and almond milk. Of course, depends on where the almonds are being grown. Growing it in California may be not a good idea. Soy milk, we saw that the animal feed that soya supplies have resulted in deforestation, so that has to be considered as well. Let's look at some environmental impacts of food and agriculture. So greenhouse gases, 26% come from food. Land use, 50% of the global habitable ice and desert-free land is going to agriculture. Freshwater use, 70% of the global freshwater withdrawals go to agriculture. In some countries it's much higher, 80-90% for irrigation. A lot of it is just loss to evaporative loss after irrigation. Eutrophication, which I think I've already mentioned, is where nutrients from fertilizers and runoff are creating conditions for massive phytoplankton blooms, which are not consumed by zooplankton quickly, so they sink and die, and anaerobic bacteria that consume this biomass end up using oxygen and create anoxic conditions, which end up creating lots of ecosystem problems, including massive fish kills and so on. 78% of global ocean and freshwater pollution comes from agriculture. 94% of mammal biomass, excluding humans, is livestock, which we know is one of the most environmentally unfriendly way to produce foods. Cows are great. I love cows, but what they do to the environment and climate cannot be ignored. There are ways to manage pastoral practices, grazing, and so on. So there are podcasts I have on that in my course on drawdown that you can look at. Global use for land production, 29% of the land is available. 71% of the habitable land is being used by humans. Of the 71% habitable land, 50% is being used by agriculture. 77% of the livestock of the agricultural 77% of this agricultural land goes to livestock, meat and dairy. And in the 20% crops, we have global calorie supply of 18% and 82% from meat and dairy, 82% from plant-based food. Of this, 37% from meat and dairy and 63% from plant-based food. Okay, so this is from meat and dairy. Of that, we are this is protein supply and this is calorie supply. One has to be careful there. Okay, so land use per kilogram. Again, beef comes. When you do it per kilogram, lamb and mutton come up on top compared to beef. Then cheese and dark chocolate. So dark chocolate is very high land use per kilogram of food. Beef, dairy, and herd comes down here. So depending on how you look at the food production's impacts, you end up with different categories of top rankers. Land use for food per 100 per 1,000 calories. I don't know, I'm having a brain fog. Beef again comes up on top, but lamb and mutton are right behind. Then come cheese, dairy, milk, and so on. Land use per 100 grams of protein. Lamb and mutton is on top now, and beef is second, cheese, milk, and so on down. So it depends on what you are seeking in your diet. In terms of share of the global greenhouse gas emissions from food, percentage-wise, China is massive at 20% and above. India, US, Brazil, Russia, and so on. So they are in the same range, and there are some countries here: Russia, Canada, Argentina, and so on are down here in the 5% or so. Okay, freshwater withdrawals. Now you get a different picture. Cheese, nuts, prawns, beef comes fifth here. Rice comes in, lamb and mutton moves down, groundnuts, poultry, meat. So freshwater withdrawals are very high for cheese, nuts, and fish. Freshwater withdrawals per 100 grams of protein. Cheese jumps up, nut comes in second, prawns jump up, milk comes in fourth, and so on. So this just gives you a sense of how things change based on what category you are looking at. Eutrophying emissions per 1,000 kilocalories. Farmed prawns are very high. Coffee is very high. Dairy herd beef, fish, beef for meat. So depends on what impacts they have on the environment, including water use, eutrophication, protein production, kilogram of food production, calorie production, and so on. Waste. One should never ever forget waste. 6% of global greenhouse gas emissions come from food losses and waste. Emissions from food that is never eaten accounts for 6% of total emissions. Lost in supply chains, consumer waste, the rest is eaten food, and then there are others. So one of the no regret decisions in terms of individual actions is to reduce your food waste. Just don't waste food. Okay? Where do the drivers of greenhouse gas emissions from agriculture come from? Population is a big one. Kilocalorie production per person has gone up. That's a big one. Emission from agriculture has gone up. Emissions per hectare have gone up, and land use per kilocalorie has dropped because the fertilizer use and other smart agriculture methods, climate predictions, better seeds, and so on have increased the yield per hectare. So land use per kilocalorie has dropped, which you think is good news, but actually unintended consequences are what we looked at in terms of water use, eutrophication, lack of micronutrients in some cases, and so on and so forth. Okay, so this concludes this book with food. Just listen to it and try to do the best you can in terms of your individual actions, but just being aware of the carbon footprint of everything you do probably will help. Think about the environment every time you do something. Okay? And we are in a carbon trap, so don't feel too guilty, but be careful nonetheless.